Hello, am I audible?
Yes, sir.
Okay. So last week you did not come, right?
या एक्चुअली वो 2 अक्टूबर था ना, तो वो हमारे यहाँ एक ट्रायल था, सब लोग वहाँ चले गए हम लोग।
नहीं,
तो
तुमने
आई
ज्वाइन तो किया था
वाज
शायद।
हाँ?
ज्वाइन तो किया था एक बार, बट
हाँ,
नहीं
वो
आया।
मैं एक्चुअली शुरू में सोच रहा था कि आपको एक बार इन्फॉर्म कर दूँ, तो उसके बाद मैं चला गया, आई वाज इन अ हरी, सो आई कुड
Okay,
नॉट टॉक टू यू एट दैट
no problem.
टाइम।
So today sir is also taking some interaction class, right? I got the mail actually.
आई थिंक इट विल बी टुमारो, आई थिंक, नॉट टुडे, 10th of October.
But in mail I think it is today it is written. दस okay, कल है, sorry.
या
So in this week mostly sir talked about some optical phase space, right?
Yeah, actually, I was unable to go through the notes today because I am also having a hectic schedule right now.
Okay,
So
okay.
I just completed only 2 classes as of now. Sir, how many more classes you are going to take? Like in the next week, it will be your last tutorial, right?
Yes, yes.
Okay, okay, fine.
But I think the last week I did not take class because nobody was there, so I have to record that one, that also. And the fifth week class I take, but it did not record it, so I have to record this again.
Oh, okay, sir. That I remember. I actually, sir, what is happening? Like, there is one. I am also having some pressure regarding this thing. So that is the issue. That's why
What?
I was unable to.
Sorry.
Huh? Actually, the workload is now
Oh,
is very
that is
hectic.
that is okay. No problem.
Yeah.
I am not complaining that you did not. I just asking that because if nobody is there, then I also have no interest to teach.
Yes, sir. I can understand. Sir, in that case, like, actually, sir, after this um, Sunday, sir, if you record any class, like after um, this, just give me 1 second. Mm, just give me one second.
Okay.
The dates I don't remember. Yeah, on this 17th or 18th October, will it be fine for you? Like, do you have?
17 or 18?
Yeah,
Uh, 17 on what day?
it is on Tuesday.
Next Tuesday, right?
Yeah.
Yeah, I can take. No, but you on Tuesday, sorry, I have a group meeting on Tuesday for my with my
Okay,
supervisor.
okay.
Every Tuesday it is happening actually.
Okay,
So
sir, just one more query I just have, like, is it possible for you to like take any class after
y-
around 9 to 11 or something like that?
yes, I can take.
Okay, sir. Sir, in that case, like, if you can, like, in Wednesday, if you give some time to me, like around 9 to 11 or something like that, that I can attend.
Okay, okay,
Okay.
fine. But this extra class I also got one that I can take some extra classes also if I want one extra class I can take. So it will be counted. Uh, so
Okay,
actually
sir,
I
in
have
that
filled
case,
that
like,
form, so I can take one extra class anytime.
okay, sir. And
But before 22, they give the deadline.
okay, sir. In that case, like,
Hello.
we can
Department,
like actually, sir, I am going to home on
department.
13th. I have train. Okay, so that's why this is there is an
Monthly
issue.
class
So
later on.
13, 14, 15, I will be in train. Okay.
और कोई
So
ठीक.
hello,
Yes,
hello.
yes, yes, बोलो.
हाँ सर, तो मैं आपको एक बार कॉल कर लूँ नेक्स्ट
हाँ
वीक,
हाँ हाँ,
मतलब नेक्स्ट, हाँ,
कर
एक
सकते.
एक आप सर, आप एक काम कर सकते हैं क्या, लाइक दिस 11th of October, you just plan it a tutorial on
11th October.
yeah, 11th
Okay.
October around 9 p.m. onwards.
Yeah, yeah, I can take.
Okay, sir. Then
On 11.
it will your classes will be also completed, and I will also get something to learn.
Okay, okay.
Okay.
11 October you are saying, right?
Yes, sir. Wednesday.
Okay, I will try. But अगर 11 को रखना है, then you can put in morning either.
Morning when, sir?
Either we can meet on Thursday
Thursday. Thursday when?
in night only, 9 to 11.
Okay, okay. That would be also fine for me. Okay.
But if 9 to 11 is, this is very hectic to all day taking meeting and then teaching. Because I was thinking Tuesday, but Tuesday my meeting is from 10 morning to
Actually,
10.
what I can see, Imani sir is taking the live interaction on basically on Tuesdays.
Yes, yes.
So that
No
will
problem.
be contradictory with you.
Okay, so we can take. I can take class on Thursday only. Is it okay?
Sir, in morning, do you have any time slot vacant for you?
Um, I'm not a morning person actually.
Okay, 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 sir. Okay, fine.
So, uh, what I'm saying that.
सर मैं एक काम करता हूँ,
So,
मैं
what do you want
आपको
in my want me to
यस
take in extra class
सर
on which topic?
फर्स्टली yeah, as we have discussed, like one, you will teach me like how the fabrication process goes.
Okay, fabrication process that is in my mind also.
Okay,
Okay.
and like the another class that is pending, that you can help me, like what should we study, like since actually, sir, what is my specialization in nano electronics and photonics. Okay,
Okay.
so the nano electronics part I understand. Okay, and photonics part also I have a grasp on that. But
Okay.
this quantum photonics part, okay, so like there are some topics are there that we should know basically for uh, to enhance our knowledge, okay, to have a overall view of this whole topic.
So
Okay,
you want me to elaborate some quantum photonics
related
related
topic.
to nanophotonics, right?
No, not related to see that nano electronics and photonics part, that I completely understand
Okay.
what is there, but this one specifically this quantum photonics part, okay, that I
So
have never
in
come
quantum
across.
photonics, see, in quantum photonics mostly is theoretical things, right? Which I
Okay,
can understood that the representation of statistical representation of light and all these things.
Okay.
it's starting something regarding some quantum photonics things.
Okay.
Okay, so okay, I will take uh, some.
Sir, one more thing, like if I ask you, like, is there any topic in photonics that you are like very familiar with that you can teach me? Is there any topic? If you can suggest something.
In photonics.
Yeah, photonics related.
So actually, my work is on bound state in continuum,
Okay, sir. Yeah, BIC. Yeah, I can attend. Okay.
and bound state in quantum is my topic. So I can little bit elaborate on this topic also. And
Okay.
other topic which I can suggest some whispering early modes things which I have done in my MTech one
Okay,
project
sir.
on this one. So I can I can take one lecture on these two, whatever I did, uh, and also what is the aspect of these things. Well,
Yeah.
more
Okay,
on
sir. Okay.
research oriented. So maybe
Okay.
this whispering early modes you can see one of fabrication which I did with my own. So I can more elaborate on that part of this one. So the point of view of this fabrication process.
Okay, sir.
Okay.
Okay.
So in extra class, so I just elaborate this Bisping early modes, which my paper is published already on this Bisping
Okay.
early modes. So I will take on this one, and parallelly I will take the fabrication, whatever the steps is given in that one, and what extra is there in the background. Is it?
Okay.
It will be okay.
Okay, sir. Fine. Like
Okay.
what you are saying, like you will take one class on fabrication and another class on this whispering gallery mode along with BIC, right?
Yes.
Okay. Okay, sir. Fine.
Okay. So sir mostly took the class on this phasor diagrams, which I can see in the uh, this assignment, previous assignment, which is
Yeah.
uh,
And sir, like one more thing, like
yeah,
sir has not uploaded any lecture notes from last few weeks.
yeah, that I also asked sir, but sir said that just see the video and make the lecture notes by yourself.
Okay. Okay.
Um,
Okay. Fine.
okay. So do you know about optical phase space?
Sir, phase space means like
Okay, come on, phase space first.
okay.
So, you know about phase space or not?
No, I can't connect at this moment.
Okay.
What is the
So, see, uh, mostly if you see the plots or some graphs, okay, of the system, so we mostly make the graphs on the spatial parameters, right? One
Yes,
is
sir.
on x-axis, another in y-axis. Then we talk about some particle is here, and this is spatial parameter x and y. Okay,
Hmm.
but uh, this is also called quadrature or some. If you read the classical mechanics, so there are two other parameters, p and q, corresponding some coordinate system. What it is called, you know, this p is
What?
corresponding to
This is
momentum.
Lagrangian Hamiltonian
Yeah,
advanced
yeah,
particle mechanics.
Lagrangian, Hamiltonian, and these are corresponding to what it is called some quantities p and q, which is converted from x to p, y to q, right?
Yes, sir.
So if you plot in this space p versus q mostly. So this
mm,
space is known as phase space, and this is known as space. This is phase space, and what it is, this is spatial space. Spatial space means you know the exact coordinate of the space, x and y
mm,
position of the particle, right? This is on xy.
yes,
But
mm,
if you have some p and q, which is mostly related to momentum and energy,
mm,
okay, so this plot is known as phase space.
okay,
Okay, because this p and maybe some you can connect like that. We have x and y value, right? So we know the energy is something around 1 by 2 k x square, right? For a simple harmonic oscillator, if we talk about in classical mechanics. So this is the energy 1 by 2 k x square, right?
mm,
And if you divide this k is given by some m by omega, right? Or sorry, k omega. So k is related to some mass of the particle. If you say this is k, so k is root fi my k, right? Something. So this k is around m omega square, right? And sorry. Uh, so you can convert this x value to p, because p is equal to m into v, right? So here is this x is m dxy dt. So this is x dot, right? M x dot is equal to p, and similarly q you can this is some t. Okay, once again. Oh, sorry, your parcel is coming from the lab. Okay,
okay, sir.
so let's start. Uh, you know about these P and Q parameter in classical, the Hamiltonian, from Hamiltonian we get, right?
Yeah,
Or if you know the dagger, or A dagger uh, operator, you know, A dagger plus A dagger. This is
acha, okay, okay.
annihilation
Annihilation and annihilation operator.
operator. Okay, so you can
Mm,
also define this Q parameter is like 1 by 2 A dagger plus minus A dagger, and P something I by 2 A dagger minus A. Okay, so this
mm,
is I think annihilator, and this is one is for generation and one is for annihilation, right? Plus
yeah,
is for okay. So if you plot, so this p is represent momentum from here, and if you see and solve some rigorous way, so this q will represent corresponding to energy, right? Momentum
mm,
and energy. So plot between momentum and energy is mainly known as phase diagram of any system. So here we check if we change the momentum, then what happens to the energy? While in the space diagram, we just give it to the velocity, right, or something. So there are some complicated like x dot and y dot terms will come, and if you solve in this space, so gives us only spatial things like where is the particle, and according to that you just calculate the velocity and all these things, right? But here this momentum and energy is given, and we can more elaborately calculate some properties like E and P very easily from this phase diagram. So if let's come to the letter. Uh, so what is the optical phase? Okay, so this is also related to quantum optics only. So in quantum optics, optical phase space is a phase space where this quantum states, you know the quantum states of the light, right?
So quantum state of the light means uh,
Sorry,
uh, what do you mean by quantum state of the light here?
quantum state means like just we calculated from many probability density, right? So here we
Acha,
will
okay,
find
fine.
some function that is the quantum state of some
Okay,
photon.
okay,
So
fine.
optical phase space, what is the sentence I am saying? So in quantum optics, this optical phase space is a phase space in which all quantum states of an optical system are described. Okay,
Okay,
so in each point in the optical phase space will be corresponding to a unique state of an optical system. Like if we have this Q and this P, okay, so
hmm.
if this is the state in this one, so this is corresponding Q and P at some state as. So each point is described a unique state of the which gives the momentum and energy, directly give you the momentum and energy of at that point. Okay,
Okay,
while if we will talk about in a spatial diagram, so I will give you x comma y, what is the position, and with extra I have to say this velocity. Mainly we have to also give in the time t space also ki what is happening to this x and y coordinate with time, right? Then only you can calculate the energy and all other properties of the system. But in this phase space there is only two coordinate. This describes all the things like p and q. So in p there is time derivative of x, while in q there is time derivative of momentum, right?
yes, sir.
So this t is already inbuilt in this space, while in this space you have to give the information along with this coordinate system, right?
Hmm.
So this is the main difference between phase space and this spatial space, which we generally saw. So just if you, let's say some state which is x at time t, we have vector function describing a single mode of an oscillator. We say electromagnetic oscillator. Okay, here. So for simplicity, if you assume that this electromagnetic oscillator is in vacuum, okay, so the plane wave you can simply write like ux comma t equal to u0 e to the power I kx minus omega t, right? So here you know this E0 is the polarization vector simply, okay, and this k is, you know, the wave vector, and omega is the frequency, right? So this a dot b, what it will give, because here is k dot x, yeah, if you write, so k dot r you write, okay. So this dot product between a and v gives the equation of plane wave, because see why this equation is known as plane wave, why not this is a spherical wave or cylindrical wave?
Yeah, because here at each point on the plane, the phase is same.
Yes, because it represents a plane where k dot x represents a plane, right?
Yeah.
Yeah. And if you want to write some spherical, then how you can write?
For spherical, I think the equation exponential term will change. Like in that case, r should be in spherical polar coordinates.
R should be in spherical polar coordinate, okay. But this R will be only magnitude, right? And
No,
also
no,
one term
it is
comes,
dot product, no?
also one term will come here,
Okay, okay, got
okay.
it.
So this will represent some spherical or spherical wave, and this is the plane wave. So mostly when we solve some problem, we start with the plane wave only to keep the things simple, because this plane wave is also when r is very greater than 1 in this formula, so you will get plane wave approximation, right? So
Yes, sir.
if you see some spherical wave from very far distance, that is also considered as a plane wave only. Do you understand
Hmm.
this point?
Yes, yes, sir.
Yeah, because like if you see like this is point, right? So here is
Hmm.
the curvature is very long, but when you come here and you take this much part, so this can be considered as a plane only, right? Not
Hmm.
the spherical surface. So that's why we consider this as a plane wave. So I was talking about this is, if this is the plane wave equation, then the oscillator being examined could either be a free wave in space or some normal mode contained in some cavity. Understood?
Okay.
So if you have some quantum oscillator mode, then the most of operator represents physical quantity which are typically expressed in terms of certain and some creation and annihilation operator, okay. So if you give the electric field in terms of annihilation and creation operator, so you can write the electric field like E I cap is equal to ui, I think some quantum state in this u, okay, and this will be of x and t, and this will be multiplied by a dagger, and another state which is defined by x at t times will be annihilation and created. See, uh, if this is just like if some photon is absorbed, some will be created, right, at a other
Yes.
point. So that only
Hmm.
that we can consider here. And if you write this E like that, so Hamiltonian you can consider like h cross omega a dagger, plus half. You already know all these formula, right?
Actually, I don't remember, but I have done these calculations
Yeah,
earlier.
this Hamiltonian in dagger form is from the simple harmonic oscillator is coming like that, because this is
Mhm.
only constant is equal to 1, so 1 plus half we can say, right?
Yeah.
So the what will be the eigen state? So Hamiltonian is already I have right. Okay. So the annihilation operator is what? The bosonic annihilation operator, and so what will this OA? This OA conical communication relation, which is uh, by name it is seems very fancy, but it is simple like that.
Hmm.
Okay. So the eigenstate, what will be the eigenstate of this annihilation operator? So just operate some state alpha on this one, so it will give some state, some eigenvalue alpha, and this state will remains constant, right? That is the definition of eigenvalue. So this eigenstate of this annihilation operator, this is only called coherent state. Okay. So in terms of annihilation and creation operator, whatever will be the eigenstate for annihilation operator, which is called coherent state. Okay. So if you want to know the total number of photon number, that you can easily calculate by multiplying creation and annihilation operator. So this gives us a number, right? That will be the
Yes.
photon number, which gives the number of photon in the given mode or given mode. I am saying given mode. So mode can be like spatial mode can also happen, or temporal mode can also happen. Okay, temporal mode or spatial mode. So spatial mode is like how, like in spatial, if you say in spatial space how small this is mode, so whatever the mode area will be, then we calculated all the mode volume and all these things, right? So in how much confined in spatial space, that is the spatial mode. Temporal mode, and on the basis of these two, the coherence is also defined: spatial coherence or temporal coherence. Okay.
Hmm.
So spatial coherence is like the phase is remains same for how long distance. That will be the length of coherence. So that is the spatial coherence of that system, whatever is it is. And for temporal coherence means how with respect time, if we say, so how long time the phase will not change, if because E is function of t and x both, right? So phase will change with time also and with space also. So whatever
Hmm.
the length in which this is phase remains same is spatial coherence, and what in time scale, if you say how long this is phase is remains same, is the uh, temporal, or it is called coherence time. Okay.
Okay.
So this is the some basic for the if you convert to the phase diagram. Okay. So we define one operator q, which will be equal to a dagger plus a. Okay. And one operator which is defined I by 2 a dagger minus a dagger. See, here it is coming I, and here it is coming, this is real and this is some imaginary. Okay. So this
Hmm.
imaginary comes in what? In time derivative it is coming imaginary, right?
Yes. In
Okay.
P dot.
Yeah, so
Uh,
this P is also related to the so if you find this value, so what it is called, this communication relation, commutative relation is there, right?
hmm. Hmm,
Some
hmm.
commutative relation is there. So we can say this q or p are as a quadrature. Quadrature means like a axis, like there are four quadratures there, quadrant. Okay. So this is
Hmm.
divided by these quadrature, right? So but here uh, they can real or imaginary or complex amplitude, this a, p and q. Okay, so if you take this commutative relation, this is comes around I by 2 if you solve this using all these formula. So from this you can calculate delta q and delta p. Okay, so this will comes like that, which is known as uncertainty principle. Okay, understood?
Yes, sir.
Yeah. So since this is coming I by 2 classical in classical mechanics, so in classical what will be the uncertainty? This will be half by 1 by 2. Okay, but when we go to the quantum region, then if you calculate this p and q and you find the communicate this commutative relation, then it comes I h cross by 2. Okay, so for quantum region, this uncertainty principle will be like this, and in classical region this will be 1 by 2 only. So these are the two different like difference between quantum and classical mechanics. uh, okay, so and like after that some other operator you can define, like phase shifting operator. Okay, or displacement operator. On basis of this p and q, uh, like if you say this phase operator, if we I plot this u theta, then it will be something I to the power theta into n cap. Here n cap I also have this, I have told you this a dagger into a, this is corresponding to some number of photons. Okay, so all these things you can, this is related to all the quantum theory which you have read. uh, Mainly this operator and all these things are defined in quantum, right, to calculate some mm, like energy or momentum. So there are the operator which we are dealing with in quantum. So and these are some quadrature you can define. So for example, this is the uh, phase diagram sir has given. So this phase diagram, we are seeing here x1 and x2, while just before I am talking about p and q, right?
Yes,
So
sir.
the first question is like phasor diagram corresponding to x1 and x2 quadrature fields are shown on this figure. So first is choose the correct phasor diagram for coherent light.
Okay, so for coherent light, I think option A will be the correct option for coherent light.
Sorry.
For coherent light, option A is the correct one. Figure A.
Yes. So why?
Because here, this straight line is representing the number of photons, and The circle is, just give me 1 second. I read it last week and forgot these things. Hmm. And this circle, I think, represents a phase or something like that.
Sorry. See.
If hmm.
mm, where I need. What is happening? I don't know. So, for the coherent light, coherent state, this phase space जो होता है, this is follow the Gaussian probability distribution. So Gaussian probability distribution will be circular, right? If you saw, like, this gives like that, okay. So but if you see, this will be the P, and this is probability density. And if you see on the two space P and Q, then, like, if you are seeing from the top, right? So if you seeing on the top, this Gaussian distribution looks like circular, right?
Okay.
So that's why this A is true. So just uh, remember this concept. The coherent state are Gaussian probability distribution over the phase space
Okay.
localized around.
Just
So
1 second,
if
sir. I
this is
just.
some state, let's say alpha
Hmm.
is the state is there, so the this will be Gaussian distributed around this alpha, Gaussian probability density distribution in this phase space. Similarly, choose the correct phasor diagram that represents vacuum field.
A vacuum field would be the circle thing at
So
0, 0.
this will be like that, right?
Hmm. Because
Vacuum field phasor diagram. This will be second question. Yeah. And the next one is choose the correct phasor diagram that represents the photon number state. So this number state means n will be some constant, right?
Yeah.
This not will be less than or equal to, this will be equal to, right? So
Hmm.
this will be something like that, and which is moving only on perimeter
Yes.
with equal distance. So this will be the
Mhm.
phasor diagram for representing photon number, because photon number is represented by this n value, right? I
Yes.
told this n is a dagger by a dagger multiplied by a. So, and what is the squeeze light, you know?
Yeah. In that case, the phase or amplitude will be a bit modified.
Yeah, so this p and q is not equal, right? Then it is squeezed in one direction, not
Yeah.
very much circular. So if I can find the figure, over 100 pages crossed in all tutorial. No problem. Just see this figure.
Yeah. Option B and D, I think.
V, D, and F also, right?
The F, I think it's representing something else rather than this squeeze state.
No, no, no. What is this representing?
Because see, when we are having
This is
uh,
vacuum field, huh?
this is vacuum field,
So
and
vacuum field if is squeezed,
hmm,
so we can also consider this as a squeezed state, but state in vacuum only, right?
okay, yes, 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 yeah, squeeze vacuum state. Okay,
Yeah. So the question was, choose correct phasor diagram for squeezed state, or which represents. So for that you can consider that vacuum squeezed state, right? According to language of the question. E is choose the correct pair of uncertainty relation. So uncertainty relation is delta x1 delta x2 is greater than equal to 1 by 4, delta x1 delta x2 is greater than 1 by 2, delta x and delta p is greater than 1 by 2, delta x and delta p
delta X and delta P will have H cut by two in them,
h cross
and
by 2, delta
yeah,
n and delta phi is greater than
it's
1 by
something
2,
half. Yeah.
and delta n and delta phi is greater than 1 by 4. So which one the uncertainty relation you can consider?
Okay, the first one is correct. First one is correct. Two. Four, option four is correct. Four and five are correct.
This one?
Option, yeah, this one and the next one.
Why this one is correct?
Which one? The last one.
The
Delta and delta five.
delta x1 and delta x2 is greater than 1 by 4.
Okay, I think that's how the A has been defined. The axis, the axis quadrature, the x1 quadrature and x2 quadrature has been defined something like that. Ki they when we multiply them, the uncertainty gives us 1 by 4.
Okay.
Actually, the circle we have drawn, na, in
Yes, yes, yes.
can you show the figure you have shown in the question just before?
Hmm.
Yeah, suppose in option A, okay.
Okay.
So if we take uh, like delta change in actually I just uh, can I show you in figure or something like that?
Okay, no problem. I
Actually,
understood.
see,
I understood. I
I
understood.
yeah, if you take uh, delta x1 radially, okay, so the uncertainty is approximately half, and part and it is perpendicular to the radial direction, it is half. So if we multiply both of them,
Okay.
we get greater than equal to 1/4.
So here are two statements in next question. Given that rega- regarding to the measurement, sensitivity, and noise level. So statement 1 is sensitivity in measurement can be improved by reducing noise below short noise limit. Sensitivity in measurement can be improved by reducing noise below short noise limit. And as 2 is subpasonian light can have noise below short noise level. So which one will be correct? So this is true, right? Sensitivity in measurement, अगर sensitivity like we have noise level and signal level, right? So signal to noise ratio should be come, should be less
Hmm.
for sensitive measurement. So that first one is true, that sensitivity in measurement can be improved reducing the noise below some certain level, and subpasonian light can also have noise below some short noise level, right?
Yes.
So both statement 1 and statement 2 are true.
Okay.
So next question is, a squeezed state is said to be detected when the fluctuation in differential current delta I output are. A squeezed state is said to be detected when fluctuation in differential current delta I output R. So option will be above photodetector saturation current, two is below short noise limit, third one is low but above short noise limit, fourth one is constant and equal to unity, fifth one is constant and equal to 0.
I think if we have the noise, just give me 1 second.
Sorry.
Below short noise limit, I think it will be we can detect the squeezed state. In that setup, like that has been given in the lecture.
Are you aware of what is short noise?
These kind of systems.
Yes.
Okay, I think what do they mean by short noise is that the fluctuation in the above the average intensity or something like that.
Yes, yes. And also like this short noise is also known as Parsonian noise, which is generated by this Poisson process. Okay, so
Okay.
that is known as short noise. So if you talk about electronics, the short noise will originate from the discrete nature of electric charge. Okay. Similarly, the short noise in uh, photonics also, this is due to photon counting in optical device, because photon is discrete in photonics, right? So where
Hmm.
the short noise will be associated with the particle nature of light, not with the wave nature of light. Okay,
Okay.
so this is the short noise definition. So okay, this below short noise limit should be there. Okay, a squeezed light state said to be detected when fluctuation in differential current should be below short noise limit. If fluctuation will be higher than this noise, then you cannot detect the light, right? Because the signal to noise ratio is something root n. So if this will be increasing, then this n will merge to your total number of photons which you are counting, right?
Hmm.
So this will be the correct answer. So question 5 is choose the correct option in regard to operator. You know this operator, right? So A option is, it is lowering operator. B option is, it is raising operator. And C is Vienn Hamiltonian at a A operator. will act on psi n, then eigen value will be En plus h cross omega, or second option En minus h cross omega. And the other options are C, D. No, D is this one. E option is when this keeps on this one, this gives En plus a dagger h omega, or En minus a dagger, sorry, not a dagger, a h cross omega. So which one will be correct about this operator? See, this is the lowering operator, and the raising operator will be like A. This one will be raising, and this one will be lowering operator. So the first option is right regarding this. And since this is lowering operator, so eigenvalue will be decreased one.
Option C will be.
This minus is here, right? So whatever energy will be, if you operate this at some state, the state will decrease to the lowering energy. The raising operator, if you operate at some state, the state to goes towards the higher energy. So this plus sign will come for this operator. Okay. Similarly, one question is regarding a dagger. So I have already told, for this one, this will be raising operator, and the eigenvalue will be plus 1. Okay. Come to the question 7. So the commutator of two quantum mechanical operator, a dagger and v dagger, how can you define the commutator? So this commutator is defined by like that, na? Do you know? A V minus B A. Have you ever seen this relation before?
Yeah, AB minus.
So this is called commutator of A and V. So see, this why this commutator we read about. So which commutator is comes to 0 means they
When this commutator becomes 0, this physical parameters can be measured simultaneously.
Yes, same. If they commute to each other, it means they cannot be measured simultaneously. And another simple question is, find the commutator of this one. how this comes to the, how can you calculate this A dagger and A commutator? Are you driving this or not?
For Hermitian, I guess A dagger is 1. Is it true?
Sorry?
For Hermitian matrices, A into A dagger is 1,
Okay.
and A dagger into A will also be 1, I guess.
Yeah, that will be one. But how can you get that number? My question is that. See, in the question there is one option one. You can tick. That is okay. My question is how can you calculate that A dagger equal to 1? Are you able to drive that A dagger is equal to 1?
Sir, A into A dagger minus A dagger into A will give this, I guess.
Sorry?
A into A dagger minus A dagger into A.
Yeah, it will come A dagger minus A dagger, then so this is also operator. This is
So
also
the rising
operator.
values of that rising operator, if we put,
See, this is operator, right? So you cannot solve until you are operating these operators at some function. So first you have to consider some function psi on which you can just operate this. Okay. Otherwise, you just choose a relation with some other operator. Like you know this P is given by 1 by 2 A plus A dagger, and Q is given by Q is given by this, P is given by I by 2 A minus A dagger, right? So you can simply just put then from here you can find what is value of A and what is value of A dagger in terms of P and Q. Okay. So for simplicity, I remember the relation, so I am writing 1 by root 2 Q plus I P, and similarly A dagger will be 1 by root 2 Q minus IP. So we have to find A dagger, right? So we will write 1 by root 2 will be common from both, right? Okay. So 1 by 2 is coming outside because first we multiply this to this. So Q plus IP and Q minus IP, and in the second term we will write q minus ip,
Q minus IP and Q plus IP.
q plus ip. So for commutator, if you know the relation, so how will you multiply? This will be q square plus p square, right? Or you can not multiply like this, because this is the scalar multiplication. You have to operator multiplication. So this will be q and q and q minus q ip, similarly plus ipq and minus ip dot p. Similarly you will find for this one. So now you have to know the characteristic, how can you this divide in the different commutator relation, right? After that you will find something like q comma minus ip and ip comma q, because other whatever combination becoming will be 0. So for these, this will be I by 2, because I coming from here, I coming from here. Okay, so since this is in plus form, so we know the computer between q to p is I. Okay, so here will be I plus I. So 2I will be here, minus will come with I. So this I to I is 2I, 2I divided by I into minus 1. So this will be I square. So I square will be minus 1, this will be plus 1, and 2 से 2 कट के this will come to plus 1. Okay. So do you understand what the calculation we are doing here? I think this will be.
Yeah,
Hmm?
yeah, I understood.
Okay, okay. So similarly, one another commutator is giving h to a dagger. So you have to find what will be the value of this commutator. Answer will be h cross omega dagger. Okay, and how will you find? Can you drive this to this? I am giving you the answer direct. Can you drive this from here to here?
Yes, sir. I think that H will be H cut omega A dagger A plus half,
A
and
dagger a
it
plus
will be
half
with A
and
dagger.
minus half. Okay.
And in the next step, we can take the H cut omega outside of that
Commutator.
operation
Yeah.
and multiply those two factors. Okay,
Okay.
so like H cut omega will come out, and there will be a dagger A into A dagger minus A dagger into A dagger into A, and from there A dagger will come out,
Yeah.
and there will be A into A dagger minus A dagger into A.
Yes, yes. Like I am just want to tell you that if you have like two operator A and V and
Hmm.
C, so you can write this like A B commute C plus uh, B V sorry A commute C B
Into
outside.
B. Yeah.
You know
Yes.
this relation, right?
Yeah, it is
Yeah.
in quantum mechanics it was there.
So
I think.
if you are using these relation, you will simply find this,
Hmm.
because H you can write A A dagger plus or minus half.
Yeah.
Anyone you can take. Okay. So no, sorry, you
It
cannot
is
take.
plus, I think. Plus
Yeah,
half.
this will be minus. If you are taking A dagger A, then you will minus, like that. This will be interchange with plus or minus.
Okay. Okay, fine.
This will be plus, this will be minus, because this relation will be, see, A dagger is gives the higher energy, then it will be minus already, like that. You can remember just. So you will simply find the relation H cross dagger will be H cross omega. If you will find H dagger and A, then what will be the commutative relation? This will be minus H cross
Minus.
omega
Hmm.
A dagger. Okay,
Yes.
whatever dagger will be, this minus will come. This will, sorry, oh, they asked with dagger one. Okay, so this will be plus. If this is A, then it will be minus, and no, not dagger.
Yeah, that's what I was getting at. Okay, fine.
Okay, so basically this was your next question in
Okay.
this part. Leibniz given are two statements in regards to communicate commutation of two quantum operator A and V. So statement 1 is giving that two operator do not commute if A dagger B dagger equal to 0, and S2 is it will not be possible to measure their value with arbitrary accuracy at the same time.
Yeah, S1 is true, and if they don't commute, we can't measure. Yeah, both of them are true.
Both are there true, and also implicate, right? Implicate
Yeah.
S1 to S2, because this
Hmm.
is true, that's why this is true, like that.
Hmm.
So next question is 12.1. Is eta is giving 1 by root 2 A plus A dagger, and some pi is given I by root 2 A dagger minus A dagger. Okay, a minus 8 आएगा, a plus 8 आएगा. So you have to find eta commute with pi. Solve it. Actually option are given, but this is pointless if I keep the answer only, because this is something to practice the mathematics of quantum operators.
Hmm.
Are you able to find?
Yeah, I'm doing it.
Okay.
Sir, is it I imaginary square root of 1 minus 1? Hello? Hello?
Hello. Huh?
I arrive square root of minus 1.
Yeah. This is okay.
Okay.
So basically, you do not need to open this one, like I initially told that this is the formula for the commutator. Okay,
Yes, sir.
because we can only open this one when we have the function, because these are operators, they cannot calculate it like this pi multiplied by psi, like that. So first you have to operator to operate this one. If we do not have, then we can just put in the commutator only whatever the definition they give, like 1 by root 2 So 2 times will no, eta will be 1 by 2, right? So this will be 1 plus a dagger, and I by 2 to 2, and a dagger minus a, because mostly people are starting with this one. We cannot operate this one until we have some function.
Yes, sir.
Okay, so
Hmm.
from here you just put take the outside, it will be I by 2, right? Root 2 and root 2 both are, if they are multiplication and you want to put in outside, that is okay, because these are scalars, but operator you cannot do in the same way. So this will be a dagger minus a dagger. So now they will split like a dagger, okay, combination with this one, then its combination with this one will be a minus a dagger, sorry, a comma a dagger, and then a dagger, and then minus a. Sorry, this is a dagger, this will be a dagger, and this, so not this will be a dagger, no, this will be a dagger, and then for this one a dagger, and minus a dagger a, like this, okay. So they will be commute each other, same operator will be, so this will be 0 and this will also be 0, okay. So this will be minus I by 2, a dagger is sorry, this will be 1 and 1, this will be 2 and they will be 0, sorry, opposite one. So this will be 2, so 2 से 2 cancel will be I, like that, okay. Question 13, which is last question. So which of the following operator pairs do not commute? A is position x and momentum p, b will be h and x, c is h and a dagger, c is a and a dagger, and e is all of above. Question is which do not commute, means you have to find x and p. So it comes some non-zero, right?
X and P. Yeah. Something IH cut or something like that.
Yeah, this comes 0, okay.
Mm.
This also comes non-zero, something h cross omega a dagger. This is also not comes equal to 0, right? So only this
Mm.
commute, and and all these are do not commute.
Okay.
A, C, and D. This is the answer. So these were the tutorial question for today. If you want to discuss anything else,
Sir, just one more thing, like, just give me 1 second.
okay.
Wrote down some question. Okay, sir. Currently, I'm unable to find that one. Okay, I will ask you next week. Okay,
Okay.
in the next.
Or
And sir, one
you
more
can
thing.
just do for WhatsApp if you have some question.
Oh, okay, sir. And just one more thing, like,
Okay.
if you don't mind, see, actually, the issue is some. I found it on the YouTube. Like, someone is recording these interactions and uploading in his or her YouTube channel. Okay, so
No,
I
no,
found.
this is my YouTube channel only.
Sir, that was your YouTube channel, that
Yeah,
Gyan or Vigyan
yeah,
Gyan
yeah,
or something.
yeah. Because I have to upload this two uploads in PMRF to show the PMRF TSA.
Okay, okay, okay. Oh, I thought someone randomly is downloading this kind of these
No, no,
videos
no.
and uploading to.
No, I
Okay,
have to
okay,
record this. That's why I'm saying.
okay. So actually, like, is it okay to keep these interactions over online,
Over online means?
like in YouTube or something like that?
Yeah, but I do not know how to stream on YouTube. I have to learn.
Okay,
Or
okay.
online you can also do. You have my number, right?
Yeah, I have your number. Like, if I just ask you, like, after this PMR thing, you got the certificate, can you please put down these videos?
Sorry,
After you, like, after this
certificate.
whole thing, like, when the classes are over, the course is over, okay? So, can you please put down these videos because, like, it's very awkward, now, keeping these interactions in.
Okay, okay, okay. I will.
Okay, sir.
Okay.
Okay, thank you very
Yeah.
much. And I will call you on Wednesday at night, okay?
Okay, okay.
To confirm the class on Thursday.
Okay, okay.
Okay, thank you very much.
Okay.